guys, today we're going to talk about the factors that affect acidity, and we're going to talk about two major ones. One, the number of oxygens on your molecule, and two, the length of your bonds. But first, we're just going to talk about the basic concepts of acids. So your basic acid has some molecule with an attached proton, and when you add it to water, it dissociates to make a proton and your anion. And this anion can be any number of things. So the first thing that we're going to talk about that affects your strength of your acid is the number of oxygens that are on this anion. So we're going to go number of oxygen. So the basic premise of what makes a good acid is how easily it breaks into these two components when you add it to water. So an acid that easily gives up a proton is going to be stronger than one that is more passive about giving up that proton. When you add oxygens to your anion, so let's say you have HClO versus HCl O2. It helps to look at the structure of these molecules, so we're going to draw them. So we have an H attached to a chlorine, which is attached to an oxygen. So there's going to be 6 electrons here, 1, 2 electron pairs here, and this one's going to look like this. Each of these has 3 electron pairs, and this will have 1 electron pair. So when you break these down in water, the anions that you're going to form are going to be ClO minus with some minus charge here, and ClO2 with some minus floating around. And so the special property of oxygen is that it's able to take this electron charge and help distribute this negative charge throughout the entire molecule so that all the negative charge doesn't have to sit on this chlorine. So chlorine doesn't really want to have an extra negative charge on it. Oxygen much prefers to have that negative charge. So the more oxygens that you have on the anion, the more opportunities you have to distribute this negative charge. So if you make another example, if you have HClO3, you'd have 3 opportunities to distribute the negative charge that would sit on chlorine after you dissociate the acid. So the more oxygens you have on the acid, basically, the more easily the negative charge of the anion is distributed throughout the entire molecule, and the more happy that anion will be in existence. So the more likely this acid will want to break up into a proton and an anion. So the more stable the anion is, aka the more oxygens it has on it, the more likely it is to form, and the stronger your acid will be. Alright, so the next thing we're going to talk about is the effect of bond lengths on your acidity. Excuse me about that. And so the important thing to note about bond length is that it follows a periodic trend. So as you go down the periodic table, your molecules are going to get bigger and bigger, and so the size of your atoms is going to increase. So if you just draw a periodic table, when you go down like this, your atom size increases. And so if you have 2 atoms bonded together, the length of the bond is going to be proportional to the actual size of the atom. So as your atoms increase in size, your bond length also increases in size. And if you think of this in just a silly little way, if you have 2 beads on a string right next to each other, it's really hard to fit scissors in between them to cut them. So that's analogous to a very short bond length, but if you have 2 beads on a string and they're really far away from each other, it's really easy to put scissors in there and cut it. So that's why bigger atoms form longer bond lengths that are easier to break. So going back to your acids, if you have a longer bond length, it's going to be easier to split this molecule into its different ions. And so as you increase the size of the atoms forming your anion, you're actually going to increase the strength of your acid. And so an example of this is on the periodic table. We have selenium and then tellurium, and they're both in the same period of the periodic table. And so HSE versus HTE, selenium is going to be slightly smaller than your tellurium, so your tellurium is going to have a longer bond length and therefore dissociate easier. So this is going to be your stronger acid compared to your hydrogen selenium. So that's about it when it comes to acidity. Hopefully that makes sense. There is a page in the newest textbook in chapter 15 that has a table that demonstrates both of those properties very well. I suggest you look at it if you're still confused. And that's it.